Good afternoon, Jill. One of the questions that we were talking about from your exam when we were connecting last night was with regards to how the t-distribution changes for different degrees of freedom. Now, I was wanting to show you this on my calculator, but I'm not getting my calculator to communicate well with my computer, so I'll just do my best to draw these on the screen. First of all, we want to recognize that t-distributions are distributions that show the averages obtained from samples of the same size. So the example I gave last night was, say we were taking samples of size 2 from the population of all Americans, and we were finding the average height. Well, in one sample of size 2, we might get two very short people that have an average of 4 feet. In another sample of 2, we might get two very large people, or very tall people, that have an average of, say, 7 feet. In other samples, we might get averages here, 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 here. We can get averages that are going to be spread out all over the place with samples that are so small, such as this, when we have only 2 people in our sample. On the other hand, when we take samples of size 100, because that sample is so large, we expect that when we average all of the people's heights within that sample, we expect we'll have some that are tall, some that are short, some that are in between, and everything in between. So what we'll find is we probably would not get an average from a sample of 100. We wouldn't get an average height of 4 feet. That would be like next to impossible because we know those are very short people, and an average of 100 people should be much closer to the true population average. So what that basically means is that with samples that come from with averages that come from small samples, there's going to be a lot of variability in the average heights that we might get. Whereas when we look at averages that come from large samples, we would expect much less variability. Because of that, the t-distribution changes with different sample sizes and therefore with different degrees of freedom. We know that degrees of freedom is determined by taking n minus 1. So if I was taking samples of size 2, those sample averages might be really, really spread out. So this is where our degrees of freedom is equal to 2 minus 1, which is 1. On the other hand, let's say I took samples of size 10. Then my degrees of freedom would be 10 minus 1, or 9. Well, I'll see that it's not as much spread out, and it's going to be taller in the middle. If I took samples, say, of size 100, then my degrees of freedom is going to be 99. And that distribution is going to look a lot like the normal curve. In fact, if I were to draw a picture of what the normal curve might look like, the normal curve is going to be closely aligned with that t-distribution that has 99 degrees of freedom. So we see much less variability in our sample averages when our degrees of freedom are higher than we see when our degrees of freedom are lower. Greater sample sizes come from distributions that are more normal and less spread out.